This is the second patterns that I have built in the UDF on the same blueprint. So the difference between pattern 1 and pattern 2 is that in pattern 2, I'm leveraging on the branching UPF to send the traffics via the N9 interface to another UPF called AnchorUPF, and then to the internet. So currently there's only one AnchorUPF being set up. You can have multiple AnchorUPF where the branching UPF will redirect to respective AnchorUPF based on the UE routing setup that you have did. So if you haven't seen the pattern 1, I encourage you to look into the pattern 1, as some of the tests, we are going to repeat the same test as what we did in the pattern 1. This is the cloud native 5G core, the baseline UDF, baselines in the UDF. So what happened here is that I have a pre-login as well. So if you have run the pattern 1 and you want to run the pattern 2, what you can do is that once you log on to the, you can do a cleanup. I'm going to run it again anyway. I already clean it up. So this cleanup will basically, what it does is that you will delete all the necessary configurations for this pattern. The same thing for the edge as well. I already did a cleanup. Alright, so there's nothing's running there. So what I'm going to do is I'm going to onboard. So for pattern 2, the UPF are exactly the same. So how to determine whether pattern 1 or pattern 2 is all the configurations is actually on the SMF. So that's where in the SMF, so for example in this pattern number 2, in the scripts what I did is that I just copy the branching UPF for the config map onto the default config map. So if you want to see what exactly is this one, for example, this is basically the SMF configurations for this pattern number 2. You can see that from here, I specified the link Gnode B to branching UPF, then from the branching UPF to the Anchor UPF 1, and all this is via the N9 interface. So what I mean is that the GTP tunnel between the UE to the UPF, and then GTP tunnel as well on the N9 interface to the UPF. So to run the pattern 2 is pretty similar. Just run the scripts. The script will copy the branching UPF config map onto the SMF, and then it will do the creations as well. So I'm going to run this. Alright, so the same thing on the client. There's no default gateway. If I just quick one, there's no default gateway. You can't get it anywhere. And as well as for the later on, we're going to create a subscriber once these things are set up. Looks like the thing's pretty quick, and you can see that it's pretty much spun up. If you look at the logs for the SMF, this is the additional things that you can see. You can see here. You can see that the send PFCP associations to two UPF, 4032 and 4030. 4032 is actually the UPF for the edge, and then 4030 is the UPF on the core. This is the Anchor UPF. So as well as you can see that there's another UPF running here. I can try to, let's say for example, if I try to delete the port on the UPF at the edge, you can see that it will set up the informations. Alright, so let's go to the test. Alright, so now I have all these ports running, and the same thing as well, I need to create a subscriber. So what happened here is that the database on these environments are purposely make it as non-persistent. So what it means is that every time when you start up the UDF, you need to create a subscriber, because the subscriber, whatever subscriber that you created in here, is not persist. It can be persist, but it is purposely done not to be persist. So if I go to the same thing as well, if I log on to the admin, so now I'm going to create a subscriber, new subscriber. The same as in pattern 1, all these are pre-populated default, and all the configuration, SMF configuration, AMF and UPF, all configuration are being default to all these informations. So pretty much you don't need to change any of this. If I click submit, so now the subscriber are created. So now I can head on to the UE clients and try to run the same script, the 3 script, 1, 2 and 3, exactly the same. Pattern 1 and pattern 2 exactly the same, only the packet flow are slightly different. So I'm going to run 0, 1. Alright, looks like this one probably take a bit longer to establish 10, 30. Sometimes got to be patient, and 10, 1, 10, 30. So probably for pattern, for the branchings, for some reasons it takes sometimes it takes a little bit of time to set up. So just have to be patient. Not yet. Okay. While waiting, let's see on the okay, we don't have a log. We do SMF. Because the buffer size is not too big. Okay, let's try again. Not yet. Oh, okay, now. Alright, so I run number 1. So what happens is that it's actually establishing, as usual, the SCTP to the AMF. I'm going to run 02, same thing. So connection setup for PDU session successful. This is new build. You can see that the tunnel is 01. The same thing as well. You can see the IPA. This is a SIM tunnel got set up. If I run 03, basically what it does is that it creates a default gateway. Now I have a default gateway to the UE SIM tunnel. If I try to ping 8888, you can see I can get to the internet. Google F5.com, and it got resolved. The same thing as well, if it wants to make sure as this pattern 2 is slightly different, I can jump onto the edge. You can confirm that actually the traffic is actually not going out to the N6 or to the internet via the edge UPF. I can jump onto the sidecar TCP dump port. If I do the same thing, TCP dump minus NNI, any ICMP. If I try to do a continuous ping on F5, you won't see anything here because the traffics are actually encapsulated in the GTP tunnel all the way from the branching UPF to the AnchorUPF. Of course, if you look for any, you can see all the UDP or all this UDP is happening between the branching UPF and the AnchorUPF. If I jump onto the UPF on the core, which is this one, if I do the same thing, NNI, any ICMP, you can see that it's actually, if I Ctrl C here, Ctrl C as well. So now you can see that actually the traffic is actually going out via the N6 on the AnchorUPF here. So if I run a TCP dump, I won't see any ICMP here because it's all GTP tunnel via the N9 interface to the UPF. And in this UPF, if I run TCP dump, I can see it on the N6, which is on the ICMP echo request. So the same things as usual. If I jump on to the com, I can get to the internet. If I go to the YouTube, if you want to do some YouTube streaming, it's possible as well. The other things that I want to quickly touch as well is that if you look at here, I don't have any edge applications running on the edge cloud. This can be configured to branch out or to create N6 interfaces or the local N6 interfaces to the intranet here. But for this demo, I don't have any applications sitting at the edge where all the applications are actually hairpinning to the UPF to the via the F5 CGN to the internet. The other things that is quickly maybe I want to show you, if I do a trace route, and let's say f5.com, if I scroll up, you can see that it's actually the traverses 10165 as the gateway. So which is this one, 10160.5 as a gateway. So all this UPF is actually default gateway to the F5 CGN. Currently the CGNet here is not being configured apart from just doing a source netting to the internet. Yeah, the same thing as well. In the real-time status, you can see the status of this connectivity. It will be the similar as what in pattern 1 as well. I think pretty much that's it. Thank you for watching.